Change is what describes our world. And when it comes to technology, we all know that these changes are Pythonized. Talking about the 80s and earlier, the word Python would raise goosebumps and many of us would run away from it in order to avoid being swallowed. Today, the same word does raise goosebumps but with a different diet. Python of the past swallowed men and Python of the present has swallowed languages. One of the biggest reasons for this magnetic Pythonization is because it can speak English unlike its rivals. The code that you write in Python can be up to 10 times shorter than that of other languages such as C, C++, Java, etc. And what is more surprising is, this Python can be learned by just anyone. So hey guys, here is Vajiha from Edureka with this magical Python tutorial which will teach you everything you need to know about Python. Of course, I'm not going to teach you how to run when you see a Python, but I can definitely help you to run your codes in Python. By the way, if you see a Python, just walk away and don't mess with it. Okay, so jokes apart, let's take a quick look at what's in store for you guys in this session. We shall begin this discussion with a small introduction to the Python programming language, covering its birth history, major projects that use Python, reasons for its popularity, features, etc. Then, we shall move on to see how to install Python and the Anaconda platform. Once we're done with the installation, we shall talk about the aspects such as naming conventions, variables, and data types in Python. Following which, we will take a look at flow control in Python. This includes loops, conditional statements, etc. Then, we shall see what are functions, data structures, and algorithms in Python. Following that, we will take a look at OOPS in Python. And lastly, we shall learn Python file handling. So before we move on, just make sure you subscribe to our channel and hit the bell icon to stay updated with all the latest Edureka videos. Also, if you're looking for a certification in Python, check out the link given in the description box below. So without any further delays, let's move on. So talking about the history of Python, Python was developed by Guido van Rossum back in 1980s and its implementation began since 1989. Python was named after the TV series Monty Python's Flying Circus. It was a successor of the ABC language and was capable of exception handling as well as interfacing with the Amoeba operating system. Python was led by Guido van Rossum for 30 years, that is, until 12th July 2018. As of now, the leadership of Python is shared by 5-member bench, namely Barry Warsaw, Brett Cannon, Carol Willing, Guido van Rossum, and Nick Coughlin. Talking about the release of Python versions, the release of Python 2 was done on 16th October 2000, and Python 3 was released on 3rd December 2008. However, Python 2.7 support has ended on 1st Jan this year. The date was actually scheduled 5 years earlier, but was postponed in order to provide ease in conversion of projects built on Python 2.7 to Python 3. The latest version of Python, that is Python 3.8, was released on 14th October 2019. So moving on, let's take a look at some of the important projects that make use of Python. Google. Yes, the world's most famous search engine is driven by Python. Python is one of the most important languages at Google. Not just the Google search engine, but Google developers of YouTube also rely heavily on Python because Python is used in almost every bit of YouTube. Dropbox. Dropbox, as many of us know, is a file hosting service that allows file storage, synchronization, cloud, etc. This award-winning application runs on Python in its backend. Quora. This website has answers to all your questions, and the developers of Quora actually rely on Python. Next comes Instagram. There might hardly be anyone who's unaware of this application. Instagram allows you to post your favorite pics and videos on a social platform with the help of Python. BitTorrent. BitTorrent is an ocean of databases and contents, but the foundation of this website is built on Python. So those were some of the major projects that run on Python. Now let's move on to see what is the reason for the popularity of Python. At number 1 is healthy active community. The backbone of every project is an active involvement of its members. The Python community provides super cool documentation of Python that allows anyone to learn it. Not just that, this community also is available to help you in case you get stuck with anything. From beginners to experts, this team is always there for you. The Python libraries. Python provides a huge number of libraries that are great for machine learning, data science, scientific experimentation, data visualizations, etc. These libraries come with huge package of functions that can be used by the programmers. Also, they come with documentations that are very convincing. Big data. One of the biggest reasons for Python's success is its big data and cloud. Python is one of the best data science language that companies look out for. It helps you bind together big data and the web and thereby considered to be the best by many in today's world. Versatile. Python can be used to develop anything such as web applications, desktop applications, games, etc. It is very much reliable and efficient as well. Accessibility. Python is one of the most accessible languages, thereby helping any newbie to learn and master it. Learners can access and execute Python without any difficulties. So those were some of the reasons for Python's popularity. Now let's move on and take a look at the features of Python. Python has a huge set of incredible features. It is an interpreted language, meaning that the instructions are executed directly without being compiled previously. It is very much readable and understandable. Plus, it's a cross-platform programming language, which means the code written once can be executed on any of the platforms with minimum or no changes. Python can be treated as a structural language, scripting language, object-oriented language, or a modular language. Python can be integrated with languages such as Java, C, C++, etc. It is also a free and open source language. So moving on towards something very interesting for Python developers, that is job trends and salary trends for Python developers. Talking about Python job trends, Python developers can hold any designation such as software engineers, Python developers, research analysts, data scientists, or a software developer. These designations can be in any domain such as big data, data science, artificial intelligence, machine learning, web development, etc. Not just that, Python developers are also among the highest paid professionals all over the world. However, the salaries may vary depending on factors such as experience, location, skill set, etc. On an average, an entry-level Python developer earns about 5 lakh INR in India and about 88K in the US per year according to a survey carried out by PayScale till June 2019. Also, salaries of Python developers vary geographically. In the US, the best location for a Python developer seems to be California, whereas in India it seems to be Gurgaon. Not to forget, let me also mention that having a knowledge of Python along with other skills proves to be a very crucial factor for influencing Python developers' salaries. The most in-demand skills preferred along with Python are AWS and Django. So that was about the job trends and the salary trends. Now let's move on and compare Python with Java, C++, and R. When compared to Java, Python proves better than Java in many cases such as the code readability, syntax, lesser legacy problems, etc. Python as compared to C++ is better in terms of code readability, the syntax, the scope of variables, etc. Python leads R in areas such as code readability, job trends, popularity, etc. So now that you're aware of Python and its importance, let's move on and see how to install this on your systems. Python can be obtained from the Python Software Foundation website at python.org. Typically, that involves downloading the appropriate installer for your operating system and running it on your machine. Now to do that, all you can do is open up your browsers and just type in python.org. Go to Downloads and download Python 3.81 for any of the operating systems such as Windows, Linux, Mac OS, or any others. Once you've selected your operating system, just click on Download and you will see that the installer gets downloaded on your PCs. Once the installation is completed, you can run the installer. To do that, just click on the downloaded file. Check the option that says Add Python 3.8 to path, and then click on Install Now. I'm not going to install this right now on my system since I already have Python 3.7 on it. Once the installation is done, just click Finish and you have Python ready to operate on your systems. So now moving on towards the Anaconda installation. Please make a note, guys, that installing Anaconda because I'll be using the Jupyter Notebook for all the codes and examples that I'll be showing in this session. So before I actually install this, let me just brief you guys with what exactly is an IDE. IDE stands for Integrated Development Environment. It is a graphical user interface where programmers write their code and produce their final products. An IDE basically unifies all essential tools required for software development and testing, which in turn helps the programmer to maximize his output. Some IDEs are generic, meaning they can support a number of languages such as Sublime Text, Atom, Visual Studio, etc. Language-specific IDEs support a specific language only. They also help you understand when you make syntax errors. Some examples of these are PyCharm for Python, JCreator for Java, RubyMine for Ruby on Rails. Talking about some more important IDEs for Python, it includes Jupyter, Spyder, Atom, etc. However, in this tutorial, I'll make use of Jupyter, and therefore, to make use of Jupyter, I'll have to install the Anaconda platform. So in order to install Anaconda, all you can do is go to the official website, that is anaconda.com/distribution. So as you can see over here, I have an option called as download. When I click on this, you will see that the Anaconda platform is available for Windows, Mac OS, and Linux. Choose the one that will suit your operating system and then click on download. Here, I'd like to advise you guys to download Python 3.7 version, as Python 2.7 has no support anymore. So that was all about the installation. Now moving on towards the naming conventions. Python's naming conventions outline the scheme for naming. Some of these are giving lowercase names to methods, instance variables, global variables, packages, modules, etc. Class names should have the first letter in uppercase followed by lowercase letters. Constants should be completely capitalized. If a name contains two words, it's good to separate those words by an underscore. A single underscore before a name means non-public, and a double underscore tells the Python interpreter to mangle those names of a class so as to avoid a clash with names defined in the other classes. So now moving on towards variables in Python. So what exactly is a variable? In any programming language, a variable is a memory location where you can store a value. The value that you have stored may change in future according to the specifications. Variables in Python can be created as soon as a value is assigned to it. It does not need any additional commands to declare a variable in Python. So now let's move on and take a look at the variable definition and declaration to understand how we declare a variable in Python. To do that, I'll jump onto my Jupyter notebook. So as mentioned earlier, Python has no additional commands to declare a variable. As soon as a value is assigned to it, the variable is declared. Say for example, I have a variable x and I assign a value, say 10 to it. Now the variable x has been declared since I've assigned a value to it. However, there are certain rules that we have to keep in mind while declaring a variable. The variable name cannot start with a number. It can only start with a character or an underscore. Variables in Python are case sensitive. They can only contain alphanumeric characters and underscores. No special characters are allowed for naming variables. So as you can see over here, I've assigned a value of 10 to this variable x. Now in case I want to print this, all I can do is just say print x. To run the code on Jupyter, you can either press Shift Enter or Control plus Enter. When you press Shift Enter, the code gets executed and the command is given to the next kernel. When you press Control Enter, the code gets executed but the command remains in the same kernel. So here I'll just hit Shift Enter. And as you can see over here, I have the value printed as 10. Variables can also hold other values such as float values, string values, etc. So taking a few examples of these, I'll take a new variable, say a, and I'll assign a value of 20.3. I'll take another variable, say b, and I'm going to assign string value to this. I'll just say hello world. So now let me just print out a and b. So as you can see over here, both the values of a and b have been printed. I'll be showing you all the in-detailed functionality of the print function later on in this session. Variables can also be redeclared in Python. This means that you can assign new values to them as and how you proceed with your program. So as you can see over here, I've assigned 10 to x. So in case I want to modify the value of x, all I have to do is just declare x with the new value. So this time, I'll just say x equals edureka. And now let me print x. So as you can see over here, previously when I printed x, it returned the value 10. Now I've redeclared x with a new value and the new value has been printed. You can either have global or local variables. Global variables are visible throughout the program, but local variables are confined to the class or the function to which they belong. So taking examples of both of these, I'll just take a variable over here, say c, and I'll assign a value to this as hello world. Now I'll create a function over here. I'll just call it as func. However, I'll be discussing about functions later on in this session. So within this function, what I'm going to do is I'll take the same variable c and I'll assign a different value to this. Say for example, Edureka. Now I'm going to run the function I just created as well as print the value of c. So I'll just call the function and then I'll say print c. Just a moment guys, I forgot to print the value of the local variable c. So for that, I'll just say print c. And now I'll run this again. So as you can see over here, the local variable c has returned Edureka, whereas the global variable c has returned hello world. Also, if you can notice over here, I've declared the value of c right in the beginning and then printed it right at the end of this program. This is because global variables are visible throughout the program. In case I remove this print statement from here and just call the function, then the global variable value will not be printed. So as you can see over here, only the local variable's value has been printed. And this local variable is not visible outside the function. So I hope you guys are clear with variables in Python. So now let's move on towards the next topic, which is data types in Python. So before we actually talk about data types in Python, let's discuss about the difference between data types and data structures. A data type is a type of data element defined by the value it holds. Some examples of these are int, float, double, etc. Data structures, on the other hand, deal with data organization, enabling the user to store, access, or modify the data. The important data structures of Python are lists, tuples, sets, and dictionaries. We'll be discussing about the data structures later on, but for now, let's come back towards the data types in Python. The data types available in Python are numbers, Boolean values, and strings. Numbers are nothing but the numerical data types. Numerical data type holds numerical values and it can be divided into integers, floats, or complex numbers. So just to show you guys an example of this, I'll take a new heading. I'll just say data types. Taking an example of the numerical data type, I'll just take a variable, say x, and I'll assign a value to this as 19. So as we all know, 19 is a whole number and this is an integer value. Also, you can assign negative values, say y equal to -4. So what I'm going to do is print out the type of these variables. So I'll just say print type of x and the type of y. So as you can see over here that they belong to the class integer. So as we all know, float values contain decimal numbers. So in case I want to declare a float variable, I'll just take a new variable, say r, and I'll assign some decimal values to this, say 45.6. Now I'm going to print the type of r. So as you can see over here, it says that this belongs to class float. Complex numbers are used to represent imaginary values. Imaginary values are denoted by j at the end of the number. Say for example, I'll take a variable s and I'll assign a value to this as 10 plus 6j. And then I'll just print out the type of it. Let me just copy the statement. And instead of r, I'll say s. So as you can see over here, it has returned that this is a complex number. So now moving on towards the Boolean type. The Boolean data type is used for categorical output since the output for a Boolean is either true or false. Now in order to show you guys an example of this, let me just take a variable, say v, and over here I'll just take two comparison values, say 2 greater than 6. Once I'm done with this, I'll print out the type of v as well as the value of v. So first I'll print out type. I'll just say type of v. And the value of v. So therefore, it belongs to the class bool and the value is false, which means 2 is not greater than 6. So now talking about strings. Strings in Python are used to represent Unicode character values. Python does not have a character data type. A single character is also considered as a string. String values in Python are declared using single or double quotes. So for an example of a string, I'll just say my string equals Edureka. And then I'll just print out my string. So as you can see over here, it has returned the value of my string. You can also access the values of a string by making use of the index values. So in case I want to access any element that is present in Edureka, what I'm going to do is just type in my string and pass on the index value of the letter that I want to retrieve. So I'll just say 4. So as you can see over here, at index number 4 is E. You can also make use of negative indices. So let's take an example of that as well. So I'll just say my string of -2. So as you can see over here, at index number -2 is A, which means starting from this special character, which is present at -1, A is present at -2. Here, I want you guys to note that positive indexing starts from 0 and increases by 1. Negative indices, on the other hand, start from -1 and move on as -2, -3, etc. So I hope you guys are clear till here. So now moving on towards flow control in Python. Flow control statements basically decide the order of execution of the program, generally accomplished through loops, conditional statements, and function calls. So taking a deep look at each of these, let us first discuss what are loops in Python. Loops allow us to execute a group of statements several times. Suppose you're a software developer and you're required to provide a software module for the employees in your office. For this, you must print the details of payroll of each employee separately. Printing the details of all the employees will be a tiresome task. So instead, you can use the logic for calculating the details and keep on iterating on the same logic statement by making use of the for loop. This will not just save you time, but also it will make your code very efficient. The illustration that you see on the screen is a flow chart for the for loop. The execution starts and then it checks for a condition to be either true or false. Condition over here can be any logic that we want to test in our program. So if it is true, it will execute the body of the loop, and if it is false, it will exit the loop. We shall discuss more about the for loop further on, but for now, let's talk about the conditional statements in Python. Before talking about the conditional statements, let's talk about what are conditions. Conditions in Python are logical conditions which we use in if and else statements. Some of the conditions in Python are the equals condition, not equals, less than or equal to, greater than or equal to. These are the conditions we often use while declaring a test expression for if and the else statements in Python. So what exactly are the if and else in Python? An if statement is used to test an expression and execute certain statements accordingly. Programs can have one or more if statements in them. The subsequent or the penultimate statement that follows is an else statement. This executes a statement in case all the test expressions in the programs are false. To understand the control flow of an if and else statement, take a look at the flowchart of how the execution takes place. So as you can see, the execution starts with a test expression. When this is true, the execution will enter the body of if and execute all the statements present there. But when this expression is false, the execution will move to the body of the else statement and execute the statements in the else block. Just like an if statement, we can also add an else if or an elif statement in Python to test out more expressions in order to optimize the code and increase the efficiency of our code. So now I'll get back to my Jupyter notebook in order to show you guys the syntax of the if-else statements. I'll just create a heading over here. I'll say conditional statements. So like I've already told y'all, the if statements come with a test expression. So what I'm going to do over here is just type in the syntax. So it starts with if. So within this, you have the test expression. Now we've entered the body of this if statement. The body of the if condition is going to contain all the statements that are going to be executed if the condition is met. So this will contain all the statements when the condition is met. In case this is not true, and if I have another if statement to be checked for, I can make use of the else if statement. So for that, I'll just write elif, and within this will be test expression 2. So what I'm going to do over here is statements when the else if condition is met. So in case both these conditions are not met, which means if they are false, okay, I'm sorry guys, I just made a mistake over here. Okay. So in case both these conditions are not met, I'll have an else block. So else, and then I'll have the final statements. So I hope you guys have understood this. So now to show an example of this, I'll take another kernel, and over here, I'll just take some variable, say x, and I'll assign a value to this as 12. Then I'll check if the value of x when divided by 3 is equal to 0 or not. So for that, I'll just type in if x mod 3 is equal to 0. I'll just print x is divisible by 3. Else, I'll just copy this print statement and I'll say x is not divisible by 3. So now let me just execute this. So as you can see over here, it says x, which is 12, is divisible by 3. So in case I want to check for this condition to be true for other expressions, what I can do is just add an else if statement. So for that, I'll just say if x mod 5 equal to 0. I'll say print x is divisible by 5. Let me just change the value of x to a number that is divisible by 5. So now let me just execute this program. So as you can see over here, I have a result saying x is divisible by 5. Now let me take a number that is neither divisible by 3 or 5. So say for example 11. So guys, the else block has been executed, and since I've not made any changes to this print statement, I have the output as x is not divisible by 3. Let me just add on another part of this statement, which is x is not divisible by 3 or 5, and execute it once again. So as you can see over here, the else block has been executed saying x is not divisible by 3 or 5. Let me just explain this once again to you all. So what exactly is happening over here is my variable x holds the value of 11. After this, my program checks if the resultant of x divided by 3 is equal to 0 or not. We all know that if we divide 11 by 3, we're not going to get a whole number, which means the quotient is not going to be 0, and therefore 11 is not divisible by 3. Then my program will enter the else if block. Here it will check if 11 divided by 5 is equal to 0 or not. As we all know, 11 is not divisible by 5, and therefore this block is also omitted. Finally, it gets into the else block. And over here, it prints the final statement. So I hope you guys are clear with this. So now let me take another example and check whether a number is prime or not using the if-else block. So what I'm going to do over here is, I'll take a new variable as a, and I'll assign the value to this as 10. And after this, the first thing that I'll have to do is check if a is greater than 1 or not. So what I'm going to do is type in an if statement. So if a is greater than 1, then I'm going to proceed with the program. So if a is greater than 1, for all the values that are present after 1, I'll have to check if a mod x is equal to 0 or not. So for x, in the range of a comma 2, which means starting from 2, I have to go on till a. I will check if a mod x is equal to 0 or not. In case a mod x, which means a divided by x, here the value of x is going to start from 2 and it will go on till 10 without including 10. So the values of x will start from 2 and go on till 9. In case 10 is divisible by any number present between 2 and 9, then a is not a prime number. So what I'm going to do over here is just say print not prime. This way, I'll be able to check for all the numbers that are present between 2 to 10. So once this is done, what I'm going to do is just break through this loop. In case this condition is not met, I'll have to type in else, wherein I'll be printing that it is a prime number. So as you can see, my internal if-else loop is completed. Now coming back towards this if statement, which checks if a is greater than 1 or not. So if a is not greater than 1, I'll just print out. So if the value of a is not greater than 1, I'll just inform the user that the value of a is not greater than 1. So I'll just say value of A is less than or equal to 1. So as you can see over here, the value of A that I've given over here is 10. Therefore, when I execute this block of code, I get the output as not prime, which means 10 is not prime. So instead of 10, if I assign the value of A as 1 and execute this program, you see that the output says value of A is less than or equal to 1, which means the final else block has been executed. Now in place of this, if I supply some prime number, say 3. So as you can see over here, when I supplied the value as 3, the output has returned saying that this is a prime number. So I hope you guys have understood this. So now let's talk about the shorthand for if and else. In case you just have one statement to execute or multiple else statements to check for, you can make use of the shorthand if and else. So to show you guys an example of the shorthand notation of if, what I'm going to do is take two variables over here, say A and B, and I'll declare A as 5 and B as 7. Now I'll make use of the if statement. So if A is less than B, I'm going to print A is lesser than B. So previously, if you've noticed, the body of the if statement is starting in the next line with an indentation. In the shorthand notation, you can make use of the statement to be executed in case the condition is met within the same line. So what I'm going to do is just give a space over here, and then I'll say print A is less than B. So as you can see over here, my if block has been executed. Similarly, you can also have a shorthand notation for the else statement. Now this is going to be a little different. What I'm going to do is first type in print A is less than B if A is less than B. Else, I'll say print A is greater than B. So as you can see over here, since A is less than B, the if block has been executed. So I hope you've understood the else if blocks completely. So now moving on towards the next flow control statements, that is the for loop and the while loop. So what exactly is a for loop? A for loop is used to execute statements once for each item in a sequence. The sequence can be anything such as a list, a dictionary, a set, or a string. For loops basically have two parts. The block where the iteration statement is specified, and then there is a body which is executed once for every iteration. In a for loop, we actually have to specify the number of iterations that must execute. So let me just get back to my Jupyter notebook to show you guys the syntax of the for loop. Before that, I'll just create a heading and I'll say for loop. So unlike other programming languages, the for loop in Python is a for in loop. So basically, for any iterator variable in the sequence, I will execute the body of the for loop that will have all the statements. So for every iterator present in this sequence, I can execute a single or a number of statements. So just to show you guys an example of the for loop, what I'm going to do is take an example list. I'll just say my list, and I'll give some random values to it. We'll be seeing how to create lists and what are lists further on in this session, but for now, let me just create a list over here. So in case you guys are wondering what exactly is an iterator, a Python iterator is a container having countable number of values. Values in a container can be traversed using the iterators. So in my case, I've taken a list as an iterator over here. Next, I'll just open up the for loop, and for every element that is present in my list, I'll say print that element. So as you can see over here, the for loop traverses each iterable one at a time, and then it executes the body for all the iterables present in my list. So therefore, for every element in my list, I'll print all elements one after the other. So now let me take another example over here. I'll say my string equals hello world. So for every element that is present in my string, I'll print that element. Sorry guys, I missed in over here. Okay. So as you can see, all the elements present in my string have been returned. In case you want to retrieve any specific element, you can make use of the index values. So what I'm going to do is just copy this. And over here, I do not want to return all the values. I just want to return the value present at some index number. Say for example 3, and I'll execute this. So as you can see, at index number 3 is L. In case I want to selectively print a section of the values present in my string, I can make use of the for loop and then slice the values that I want from my string. So for that, I'll just copy this. I'll paste it over here and I'll say print all the values from 0 to 3. So as you can see, from index number 0 to index number 3, I have all the values that are printed. Please make a note over here that it starts from 0, goes on till 3, but it does not print the value present at index number 3. Similarly, in case I want to print all the values that are present after 3, I can slice my string and print all the values that are present after 3. So as you can see, I've not given any value after this colon, which means I want to print all the values that are present after 3. Similarly, you can also make use of negative indices. So I'll just copy this. I'll say print the value that is present at -3. So for our coincidence, the element that is present at -3 also is L. That is because this special character is present at -1, D is present at -2, and L is present at -3. So I hope you guys are clear with this. So now moving on towards the while loop. The while loop executes the set of statements as long as the condition is true. It consists of a condition block and the body with a set of statements. The while loop keeps on executing until the condition becomes false. So in case you want to make use of a while loop, you'll have to keep 3 things in mind. The first thing is to initialize your iterator. The second is to specify the condition. And the third is to increment your iterator. In case you do not increment your iterator, the while loop will go on forever. So what I'm going to do over here is take a small example of the while loop. Before writing down the example, let me just write down the syntax of the while loop. So that is while, some expression, and then the body which contains the statements. So now let's move on towards an example of the while loop. So I'll take an iterator over here, say I, and I'll initiate the value of I to 0. So now my iterator value has been initiated. So this was the first rule for my while loop, which is initializing the iterator. The second is to specify the condition. So I'll just take in the while loop. I'll specify the condition as while the value of I is less than 4, I want to print the value of I. And the last bit of this is to increment the value of this iterator. In case I do not increment this, it will keep on printing the value of I infinite number of times. So I'll just say I plus equal to 1. So I'm incrementing the value of I by 1 each time. So now let me just execute this. So as you can see over here, it prints the value of I unless and until it is less than 4. So therefore, the initial value of I is 0 and the first value in the output is 0 as well. The second value will be taken by incrementing the value of the iterator by 1. Therefore, I becomes 1 and since I is still less than 4, I'll print I. Next, I'll increment the value of I again by 1, which is 1 plus 1 and that will be 2. 2 is still less than 4, therefore I'll print 2. After that, I'll add 1 to 2 again, which will give me 3. The value of 3 is still less than 4. I'll print 3 and then I'll increment the value of I. This time the value of I will be 4. So 4 is not less than 4, which means I'll exit the while loop. So I hope you guys have understood this. So now moving on towards something very important, which is the loop control statements. I'm sure many of you all would have come across the statements such as break, pass, continue, etc. These statements are nothing but the loop control statements. The loop control statements are used to control the flow of the loop or to alter the execution based on a few specified conditions. In Python, we have break, continue, and pass as the loop control statements. The break statement is used to terminate the execution of a loop containing it. As soon as the loop comes across the break statement, the loop terminates and the execution is transferred to the next statement. Here, I'll say for x in Edureka. If x is equal to r, I'll break the loop, which means when I encounter R, I want to break through the loop. And I do not want to continue the loop for the rest of the elements. And then I'll just say print X. And finally, I'll just say print loop has ended. Sorry guys, I just made a mistake in the indentation over here. So as you can see over here, all the elements that are present till R have been returned, which means edu have been returned and then the loop has ended. So now talking about the continue statement. The continue statement is used to skip the rest of the code in the loop for the current iteration. The continue statement, however, does not terminate the loop like the break statement and continues with the remaining iterations. So basically, when a continue statement is encountered, it only skips the remaining loop for that iteration. So let me just try this out over here. So instead of break, I'll say continue. So when R is encountered, the value is skipped, which means when R is encountered, the print statement is not executed. So now talking about the pass statement. The pass statement is a null operation. It basically means that the statement is required syntactically, but you do not wish to execute any command of code. So in case if I change this from continue to pass and add a print statement that is to be printed when R is encountered, I'll just say pass executed. So as you can see, when R is encountered, this print statement is executed and then the loop continues. So talking about nested loops. Python also allows us to use one loop within another. You can use a for loop within a while loop and a while loop within a for loop as well. So to take an example of this, let me just say for x in range of 1, 10, and then I'll take another for loop within this for loop. I'll say for y in the range of x, I'll say print x. So instead of ending this print statement with a next line character, I'm going to use the end parameter as a space character. So for all the values that are present between 1 and 10, each time I take the value and in that range, I'll print the value. So for the first time, I'll have x as 1. So for 1 in the range of 1, I'll say print 1. Therefore, 1 is printed just once. For the second iteration, I'll have the value of x as 2. So for 2 in range of 2, I'll print 2, which means I'll print 2 twice. Now since my output does not look too formatted, what I'm going to do is add another print statement to create some beautiful looking output. So as you can see over here, I've created a number pyramid. So I hope you guys are clear with this. So now let's take an example of a nested while loop. So what I'm going to do over here is take a variable, say a, and I'll assign a list of values to this. So while a is true, what I'm going to do is just print a.pop -1. And then I'll take another variable within this while loop. I'll just say b is equal to some list of string. Let me just take a symbol that will differentiate between these two loops. So next, I'm going to take another while loop and I'll say while b is true, print b.pop of 0. So as you can see, both my while loops have been executed. So I hope you guys have understood this. So next, what I'm going to do is print the Fibonacci series using both the for loop and the while loops. I already have a code for that. So let me just copy it and I'll paste it over here. So as you can see, what's happening over here is I've defined a Fibonacci function, and over here I'm assigning the value of first and second as 0 as 1. Then while this is true, I'm going to yield the value of f. In case you want to know more about the yield function, you can actually check out generators in Python video. So moving on, once the value of f has been returned, which means if the first value has been returned, I'll have to change the value of first as second, and the second will be first plus second. So therefore, first becomes second and second becomes f plus s. Next, I'm taking the for loop for every element that is generated by my function. In case the value of x is less than 50, I'm going to print the value and I'm going to end it with a space character. In case the value of x becomes greater than 50, all I have to do is break the loop. So I hope you guys have understood this. Okay, so now moving on towards the next topic of this session, which is functions in Python. Before discussing what exactly are functions, let's figure out why do we need Python functions. Functions are used to manage inputs and outputs in a computer program. Programming languages are designed to work on data, and functions are an effective way to manage and transform this data. The modifications are generally done to drive outcomes like performing tasks and finding results. The set of operations or instructions required to do so comes from logically functional blocks that can be reused independently from the main program. In fact, the main code is also a function, just a very important one. Every other function is logically aligned and maintained to functionally execute your main code. But if the function has not been defined previously, you'll just have to define one yourself before using it. This is because the function definition lists the steps of operation. So basically, functions are nothing but tasks that the user wants to perform repeatedly. By defining it just once with a name, the user will be able to use the function anywhere in the program. This not just reduces the size of the code, but also helps in debugging. So now coming towards what exactly are Python functions. The functions in Python are a classic example of such reusability. So, to serve a wide range of applications from GUI and mathematical computing to web development and testing, Python's interpreter already comes equipped with numerous functions that are always available for the use. Also, you can add on libraries or modules to your program that contain predefined functions readily available for use. So now talking about the types of functions. In Python, you can either have built-in functions, lambda functions, or user-defined functions. So taking a look at each of these in detail. So Python built-in functions. Built-in functions are nothing but the functions that are provided by the Python interpreter. Some examples of these are the print function, the sum function, min-max functions, etc. Now let's get back to our Jupyter Notebook and see how you can make use of these built-in functions. The first function that I'll be discussing over here is the print function. I'm sure you all know the print function. Print in Python is a standard function that is used to print the output to the console. Let me just create a heading over here. I'll say functions. To show the syntax of this function to you guys, I'll make use of the help function. So help on the print function will return all the documentation about the print function in Python. So as you can see on the screen, the print function takes a number of parameters. Value is nothing but a value or a set of values that has to be printed out to the console. A separator will decide how the values are separated from each other. The end parameter is used to specify what is to be printed at the end of the output. Default value for the end parameter is /n, meaning next line. Next is the file parameter. This is an optional parameter which comes with a write method. The default value of this is sys.stdout. Flush is also an optional parameter that is used to specify if the output has to be flushed or is it to be buffered. If the output has to be flushed, the Boolean value will be true, and in case if it is buffered, the Boolean value will be false. The default value for this is false. So now let's take a few examples of the print function. So the first thing that I'll print is hello world. Next, I'll take the same function and over here, I'll print it as two different strings. What I can also do is add a plus sign in between this. So I'll just copy this and I'll add a plus sign over here. So as you can see over here, the first statement is printing the hello world string as it is. In the second statement over here, I'm printing hello world as two different strings. In the third example, I've made use of a plus operator, which means I want to add the first string to the second string. I can also add in some numerical values, say 2020, and then print it. So here it is, hello world 2020. Now what do you mean by a separator? In case you want to use a separator, what you have to do is I'll just take this example, and instead of separating them by a space, let me separate them by something else. So I'll just say separator should be a hyphen. Okay, so as you can see over here, in place of a space character, I've got a hyphen. So if I have two print statements, one after the other, I can change the end parameter from next line to something else. So what I'm going to do is, I'll say hello world Edureka. And in the first print statement, I'll make use of the n parameter and I'll specify it to be a dashed line. So as you can see over here, the outputs of both these print statements have been printed in the same line, but they are separated with this dashed line over here. So I hope you guys are clear with this. So now let's talk about the min-max functions. The min-max functions are also built-in functions that are present in Python. So in case I have a list of values, say A, and if I want to find the minimum and the maximum of this, all I can do is make use of these functions directly. So I'll just say print the minimum of A and the maximum of A. So as you can see over here, the minimum value that's present in A is 1 and the maximum value present in A is 7. Another commonly used function of Python is the sum function. This function will return the sum of all the iterables that are given as a parameter to it. So I already have my list over here as A. I'll just say sum of A. So as you can see over here, it has summed up all the values present in my list and it has returned the value as 28. One more thing I want you guys to note over here is the sum function actually has two parameters. Now to show that to you guys, let me just type in help for the sum function. So as you can see over here, the sum function has two parameters, which is the iterables and the start. Iterables over here is the sum of iterables whose value needs to be summed up. The second parameter is the start parameter, which is by default 0, meaning the sum of all the iterables should be added to 0. So it will be 0 plus sum of all the iterables. In case I specify some value to the start parameter, it is going to add that value plus the sum of all the iterables. So in the previous example, if I have sum of A, 10, it's going to add 10 plus 28 and return the amount. So as you can see over here, it has returned 38, which is 28 plus 10. So I hope you guys have understood this. So now moving on towards the next topic, which is Python lambda functions. Python lambda functions are functions that do not have any name. They are also known as anonymous or nameless functions. The word lambda is not a name, but it is actually a keyword. This keyword specifies that the function that follows is anonymous. How do you actually write lambda functions in Python? A lambda function is created using the lambda operator. Okay, so now let me just type in the syntax of a lambda function. So basically, it will be the lambda keyword, followed by the arguments, and then the expression. Here, arguments are nothing but the variables that are used with this lambda function. Expression is a mathematical expression that will decide the output. Lambda functions can take any number of arguments, but they can take just one expression. Arguments can be anything starting from 0, and there is no upper limit. Just like any other function, it's perfectly fine to have lambda functions with no inputs. So now let's just take an example of a lambda function. So I'll just take a variable A, and now I'll make use of the lambda function. I'll just take one argument for the first example. I'll say lambda x, return x star x. And now I'll say print A of 3. So as you can see over here, I've got the output for x star x when A is 3, and therefore the output is 9. Let me take another example with two arguments. I'll just say B equal to lambda x comma y, and I'll say print x plus y. I'll pass the parameters for x and y as 1 and 2. I'm sorry guys, instead of taking B of 1, 2, I took A of 1, 2. So here it is. I found the result for x plus y, which is 1 plus 2, and that is 3. So I've taken two examples over here, but please make a note that both the functions have a single expression. So now moving on towards user-defined functions. Functions that we define ourselves in a program in order to achieve some task is referred to as a user-defined function. So the syntax for a user-defined function will be the def keyword followed by the name of the function and then the arguments. You can have any number of arguments, guys. Then comes the body of this function. The body of this function can have any number of statements. So I'll just write statement 1, 2, etc. So as you can see over here, the first thing that you'll have to do is make use of the def keyword. Now this keyword will actually help you to define your own function. Next up will be the name of the function. Then you'll have to pass in the arguments of your function, which can be any number of arguments starting from 0. The body of the function can have any number of statements in them. So now let's move on and create some user-defined functions. So what I'm going to do over here is create a function to add two numbers. So I'll just say define add function. I'll specify the parameters as x and y. And I'll just say the sum is equal to x plus y. And I'll return the value of sum. After this, I'll just have to call the add function and pass the values of x and y. I'll say 2, 4, and I'll run this. So as you can see over here, I have the output for 2 plus 4, which is 6. So now that you've seen what are user-defined functions as well as lambda functions, let's take a small example wherein you can make use of the lambda function within a user-defined function. So what I'm going to do is define a function over here, say new function, and to this, I'll just give one parameter as x. Now this function will just return one statement, that is the lambda function. The arguments for this function will be y, and I'll specify the expression as x star y. Now I'll take a new variable, say t, and now I'll have to call the user-defined function, which is new function. What I'm going to do is just print t of 5. So as you can see over here, my function takes one parameter as 3. So x over here is 3 and y is 5. Now if you're wondering why 3 is assigned to x and 5 is assigned to y, this is because I'm specifying 3 as the parameter of my new function. Then within this function, I've made use of the lambda function, which takes one parameter. Therefore, this parameter is supplied the value as 5. So I hope you guys are clear with this. So now moving on towards the next very important topic of this session, which is data structures in Python. So what exactly is a data structure? Data structures allow you to organize your data in such a way that it enables you to store collections of data, relate them, and perform operations on them accordingly. Python has implicit support for data structures, which enables you to store and access data. These special data structures of Python are nothing but lists, dictionaries, tuples, and sets. Python allows its users to create their own data structures as well. The most prominent data structures of this section are stacks, queues, trees, linked lists, and so on. So now talking about the built-in data structures of Python. Lists. Lists are used to store data of different data types in a sequential manner. There are addresses assigned to every element of a list, which is called as the index. The index value that starts from 0 and goes on until the last element is called as the positive index. Negative indexing starts from -1, that is, from the last element that is present in your iterable. Therefore, positive indexing starts from the left-hand side and moves towards the right-hand side, whereas negative indexing starts from the right-hand side and moves towards the left-hand side. So now let's get back to our Jupyter Notebook and see how to create lists in Python. To create a list in Python, you can make use of the square brackets and add elements in it accordingly. In case you do not pass any values, the list is going to be empty. So I'll just take a new list over here. And I'll assign some random values to it. Okay, I'll take another list. I'll say my list. And I'll not assign any value to this. Then I'll just print the values of both these. So as you can see over here, new list contains a list of elements starting from 1 to 7 and my list is empty. Not just this, you can also make use of the list function to create a list. So I'll just take a new variable, say a, and I'll say this is equal to list of, I'll specify an empty list. Now let me just print out a. So as you can see over here, I've created an empty list making use of the list function. Now since lists are mutable, you can add on values or delete values from lists. In order to add elements to a list, you can make use of the append, extend, or the insert functions. The append function can be used to add a single element to your list. The extend function will add a number of elements one after the other to the list. The insert function, on the other hand, will insert an element at a specified index value in your list. So let's take an example of all these three. So I'll just say a.append, and I'll specify a value, say 3. Next, to new list, I'll add on a number of values. I'll say new list.extend, and I'll give a list of values. Also, I'll make use of the insert function. I'll say new list.insert. I want to insert the value at position 2. And here, I'll insert a string. I'll say Edureka. Now let me just print all these. I'll print A. So as you can see, previously A was empty, but after making use of the append function, I've added 3 to my list. So now in case I want to see what's present in new list, I'll just say print new list. So as you can see, 9 and 10 have been added to the end of my list, and Edureka has been inserted at index number 2. So 1 is at index number 0, 2 at index number 1, and Edureka is present at index number 2. So that was about adding elements to a list. Elements can also be deleted from a list. In case you want to delete elements from a list, you can either make use of the pop function, the remove function, or the delete keyword. Now let's take an example of each of these. For my new list, what I'm going to do, I'll say new list.pop of 2. And then I'll say print new list. As you can see over here, the value that's present at index number 2 has been removed from my list over here. On the other hand, if you make use of the remove function, you'll have to specify the value to be removed instead of the index number. So over here, I'll just say new list.remove, and I'll specify the value to be 10. And then I'll just print it. So as you can see, 10 is not present in my list anymore. Similarly, if I make use of the del keyword, I can delete some element that is present at some particular index number. I'll say delete new list of 5 and then print new list. So as you can see over here, the element that is present at index number 5 has been removed. Elements of a list can also be accessed by using the for loop. So in case I want to access all the elements that are present in new list, all I have to do is use the for loop. So for x in new list, I'll say print x. So as you can see, all the elements have been returned one after the other. You can also slice the new list from some particular range. So I'll just print all the elements that are present after index number 2. Sorry guys, I said I want to print all the elements that are present after 2, but here I specified :2, which means I've printed all the elements starting from the index number 0 to 2. There are a number of other functions that you can also use, which is the length function to find the length of the list, the index function which finds the index value of the value passed as a parameter and the first occurrence of it, the count function which finds the count of the value passed to it. You can also sort the list by making use of the sorted or the sort functions. So now moving on towards the next data type, which is a dictionary. Dictionaries are used to store key value pairs. To understand it better, think of a phone directory where hundreds and thousands of names and their corresponding numbers have been saved. Here, names will be the keys and the phone numbers will be the value pairs for that keys. In Python, dictionaries can be created using the flower brackets. You can also create them by making use of the dict function. So now let's get back to our Jupyter notebook and create some dictionaries over here. I'll just take a variable, say A, and then I'll open the flower brackets. I'll take the keys as numbers. So I'll just say 1 is hello and 2 is world. And then I'll just print out A. In case you do not specify any parameters, an empty dictionary will be created. So I'll just take an example of that over here. I'll say B is equal to flower braces, and then I'll print B. So as you can see over here, an empty dictionary has been created. You can also create dictionaries by using the dict function. So I'll just say C is equal to dict of, and I'll copy the same thing. So as you can see over here, I've created a dictionary by making use of the dict function. So now let's move on and see how you can actually change and add values to dictionaries. Values of a dictionary can be changed by using keys. So the first thing that you'll have to do is access the key and then change the value accordingly. So in case I want to change the value of 2 over here, what I'm going to do is C of 2 is equal to Edureka. And then I'll print C. So as you can see over here, the value for 2 has been changed from world to Edureka. In case you want to delete items from a dictionary, you can make use of the pop function, the pop item function, or the clear function. The pop function will return the value that has been deleted. The pop item function will return a tuple of the key and the value. To clear the entire dictionary, you can make use of the clear function. So let me just show you an example of this. I'll say c.pop, the value present at index number 1. So as you can see over here, hello has been removed from my dictionary. In case I make use of the pop item function, it's going to return both the key value pair. So as you can see over here, the pop item function has returned both the key value pair that has been removed. Now my dictionary is empty. In case I want to delete this dictionary, I can make use of the clear function. So I'll just say c.clear. My dictionary is already empty and I don't actually have to make use of this function. I just typed this function over here to show you guys how to use it. The values of a dictionary can also be accessed. Now to access the values, you'll have to make use of the keys only. To do this, you can either make use of the get function or directly specify the name of the key. I'll just create a new dictionary over here. I'll say D is equal to 1 is to Python, 2 is to Java, and 3 is to C#. Now, I want to retrieve the values that are present for the keys 2 and 3. So what I'm going to do is use the print function, and within this, I'll specify the name of my dictionary, and then in the first example, I'll just specify the key value, and in the next example, I'll make use of the get function. I'm sorry guys, I've not executed this line over here. So as you can see over here, the value present for key 2 is Java and that for key 3 is C#. So now talking about tuples. Tuples are actually the same as lists, but with one exception that the data once entered into a tuple cannot be changed no matter what. To create a tuple in Python, you can make use of the regular brackets. You can also create a tuple by making use of the tuple function. I'll just create my tuple. And in the first case, I'll create an empty tuple. Next, I'll create another tuple, say z, and I'll assign some values to this. I'll take another variable y, and then I'll make use of the tuple function in order to create a tuple. Now let me just print out each of these. I'm sorry guys, I've missed regular braces over here. So as you can see, an empty tuple has been created, followed by a tuple using the regular braces, and then a tuple making use of the tuple function. Like I've already told you all before, you cannot alter the values of a tuple. So in case I use any function such as an append function with a tuple, it's going to throw an error. So now just to show this to you all, I'll say y.append, I'll say 3. So as you can see over here, it has thrown an attribute error saying tuple object has no attribute append. In case you want to access the elements of a tuple, all you have to do is make use of a for loop. So I'll say for I in y, print I. So as you can see, all the elements of the tuple have been retrieved. One more thing I want you guys to note over here is that in case you want to add on some elements, you can make use of the plus operator. So now moving on towards the next data structure, which is a set. Sets are a collection of unordered elements that are unique, meaning that even if the data is repeated more than one times while specifying the values, the set data type is just going to take one entry of that element. Sets in Python actually resembles the sets that you've learned in arithmetic. The operations are also the same, such as intersection, difference, union, etc. To create sets in Python, you can make use of the flower braces, and instead of adding the key value pairs, you just have to specify the values. Now let me just get back to my Jupyter notebook and show y'all how to create sets in Python. Like I've already told y'all, sets are created by making use of the flower braces. I'll just take a variable over here as x, and to this, I'll specify some values. And then I'll just print the set. So as you can see over here, I supplied 8 values, but only 5 values are present in my set. Now this is because I have 3 repeated values, and those values are not printed again in my set. In case you want to add some values to a set, you can make use of the add function. So I'll just say x.add, and I'll pass the value as 8. Now let's just print out x. So as you can see over here, 8 has been added to my set. You can perform many operations on set, such as intersections, unions, difference, etc. Now what I'm going to do is define another set over here. I'll say y. Y is equal to some random values. So in order to find the union of x and y, I can either use a pipeline character or make use of the union function. In case I just want to find the union of x and y, I'll say z is equal to x pipeline y, and then I'll print z. Sorry, I've taken cap C over here, which is small actually. So as you can see, I have the union of x and y present in z. Similarly, I can also make use of the union function. To do that, I'll just make use of the print function, and then I'll say x union y equals x dot union of y. So as you can see over here, I found the union of x and y. Similarly, you can also make use of the difference function, the intersection function, etc. So let me just change this from union to intersection and see what happens. So as you can see over here, I changed the value from union to intersection, and therefore I found the intersection of x and y. I just have to make a change over here as well. Okay, so I hope you guys are clear with this. So that was about the built-in data structures of Python. Now moving on towards the next topic, which is user-defined data structures. User-defined data structures can either be arrays, stacks, queues, trees, linked lists, graphs, or hash maps. An array is basically a data structure which can hold more than one value at the same time. It is a collection or ordered series of elements of the same type. We can loop through the array easily and fetch the required values by just specifying the index numbers. Arrays are mutable, which means they are changeable, and therefore you can perform various manipulations operations as required. Stacks. Stacks are linear data structures which are based on the principle of last in, first out. Here, the data which is entered last will be first to get accessed. It is built using the array structure and has operations, namely pushing or adding elements, popping or deleting elements, and accessing elements only from one point in the stack, which is called as the top. This top is the pointer to the current position of the stack. Stacks are prominently used in applications such as recursive programming, recursive words, undo mechanisms in word editors, undo mechanisms in word editors, and so forth. Queues. A queue is also a linear data structure which is based on the principle of first in, first out. Here, the data entered first will be accessed first. It is built using the array structure and has operations which can be performed from both ends of the queue, that is, the head, tail, or the front back. Operations such as adding and deleting elements are called as enqueue and dequeue. Queues are used as network buffers for traffic congestion management, used in operating system for job scheduling, and many more. Trees. Trees are nonlinear data structures which have roots and nodes. The root is a node from where the data originates, and the nodes are the other data points that are available to us. The node that precedes the parent and the node after is called as a child. Levels of a tree shows the depth of information. The last nodes are called as the leaves. Trees create a hierarchy which can be used in a lot of real-world applications such as HTML pages, which use trees to distinguish tags that come under the same block. It is also efficient in searching purposes and much more. Linked lists. Linked lists are linear data structures which are not stored consequently but are linked with each other using pointers. The node of a linked list is composed of data and a pointer called next. These structures are most widely used in image viewing applications, music player applications, and so forth. Graphs. Graphs are used to store data collection of points called as vertices and edges. Graphs can be called as the most accurate representation of real-world map. They are used to find the various cost to distance between various data points called as the nodes and hence find the least path. Many applications such as Google Maps, Uber, and many more make use of graphs to find the least distance and increase profits in the best ways. Hash maps. Hash maps are the same as what dictionaries are in Python. They can be used to implement applications such as phone books, populate data according to lists, and much more. So now let's move on and discuss what are algorithms in Python. Algorithms in general are rules or instructions that are formulated in finite sequential order to solve problems and get the required results. They give a pseudocode for problems and can be implemented in several languages as they are not language specific. So how do you write algorithms? Algorithms are generally written as a combination of user understandable language and some common programming languages. They are commonly written in steps. However, it is not always necessary to do so. There are no distinct rules to formulate algorithms, but you will need to keep the following points in mind. Figure out what exactly is the problem, determine where you need to start and determine where you need to stop. Formulate the intermediate steps, and finally review your steps. Say for example, if you have to formulate an algorithm to check if a student has passed in an exam or not. So after you start, you're going to declare two variables, say x and y, and then you're going to store the marks obtained by the student in x and store the minimum passing score in y. Then check if x is greater than or equal to y. If yes, then return pass, else return fail. And finally, you'll have to stop. So this was an example of an algorithm to check if a student has passed or failed. However, you can manipulate the steps according to your preference. For example, you can assign values to both variables x and y in a single step rather than two steps. So this way, a single problem can have multiple solutions, and it depends on the problem and the programmer to choose the most feasible and the reliable solutions. So now, let's understand what are the elements of a good algorithm. Good algorithms need to have finite, clear, and understandable steps. There should be a clear and precise description of the inputs and the outputs. Each step needs to have a defined output that depends only on the inputs in that step or the preceding steps. The algorithm should be flexible enough to mold it and allow a number of solutions. The steps should make use of general programming fundamentals and should not be language specific. So what are the classes of algorithms available for programming? The three major algorithm classes are divide and conquer class, dynamic programming, and the greedy algorithm class. The divide and conquer class divides the problem into subparts and solves each of them separately. Talking about dynamic programming, it divides the problems into subparts, remembers the results of subparts, and then applies to the similar ones. This way, there'll be lesser number of repetitions when compared to divide and conquer method. Greedy algorithms involve taking the easiest step while solving a problem without worrying about the complexity of the future steps. So now let's move on and take a look at the important algorithms such as tree traversal algorithms, searching algorithms, and sorting algorithms in Python. The first that I'll be discussing in this session is the tree traversal algorithm. Trees in Python are nonlinear data structures having a root and node as mentioned earlier. Tree traversal refers to visiting each node present in a tree exactly once in order to update or check them. So based on the order in which the nodes are visited, there can be three types of traversals. That is the pre-order traversal, in-order traversal, and the post-order traversal. Before moving on in detail about each of these algorithms, what I'm going to do is jump onto my Jupyter notebook and create the tree that you see on your screens. I'll create a heading over here. And I'll just call it as tree traversal. So like I've already told y'all, I'll be writing down the code to create a tree first. So for that, let me just create a heading. This will be in H2, so I'll have to have two hashes. And then I'll just say creating the tree. So the first thing that I'm going to do over here is define a class called node. So class node. In case you have any issues understanding classes and objects, don't worry guys, because I'll be discussing each of this in detail later on in this session. So for now, I'm just defining a class within which I'll define a function, that is the init function. And then the mandatory parameter, which is self, followed by the value parameter. Now this self parameter will allow me to access the variables of this class. All the details about classes and this self parameter I'll be discussing later on in this session when we go on to OOPS in Python. So for now, I'll just write self.leftChild, or I'll just say LC equals none. Now I've specified none over here because right now there is no left child. The first value should be assigned to the root node, and therefore the left child and right child will contain nothing, and therefore I'm assigning none to it. Similarly, I'll write self.rightChild equals none. Finally, self.nodeData will be equal to value. So now let's move on and create an object of this class. So I'll just call the object as root. And you guys have seen already that in my tree, the first root or the root node is 1. So therefore, I'll assign a value as 1. So once this is done, I'll have a root node that is created. So once the root is created, I'll have to create the left child and the right child for it. So now what I'm going to do is root.leftChild will be equal to node of 2. And root.rightChild will be node of 3. So in my tree, the node 2 has another left child and a right child. So to create that, what I'm going to do is write down root.leftChild is equal to node 4. And finally, the right child of node 2 will be node 5. So I hope you guys are clear with this. Let me just draw this and explain this to you guys. So at the first step, I'll have my root node that is created, and that will be node 1. Following that, I'll have a left child for this node, so that will be 2. And then a right child will be created for 1, that is 3. Now again, node 2 will have 2 childs, that is left child will be node 4 and right child will be node 5. So I hope you guys are clear with this concept. So now I'll just erase this drawing. So now let's move on and see how you actually do the in-order traversal. In-order traversal refers to traversing the tree in such a way that you first visit the left nodes, followed by the root and then the right nodes. You begin your traversal from all the nodes in the left subtree, then move towards the root, and finally the right subtree. So if I have to implement the in-order traversal over here, what I'm going to do is, I'll just create a heading. I'll say in order. Since I have my base tree already created over here, all I'm going to do is just define the in-order function. So the first step of in-order traversal will be to traverse through the nodes present in the left subtree. Then at step 2, I'll have to visit the root and finally the right subtree. So now I'm going to define a function. I'll call it as in-order. And then I'll pass a parameter as root. So if a value for the root is present, what I'm going to do is call the in-order function. And over here, I'll first visit the left child, so root of left child. And then I'll print the value for the root. Okay, sorry guys, if root, I just missed that. So once I visit the left child and the root, I'll have to visit the right child. So I'll say in order of root.rightChild. After this, I'll have to call the in-order function. So in order of root. So as you can see over here, the in-order traversal starts from 4, moves on to node 2, then 5, 1, and 3. So in this tree over here, for the in-order traversal, it will start from the leftmost node. And the leftmost node in my tree is node 4. So it will start from 4, then it moves towards the root, and finally the right node. Once I'm done with 4, 2, and 5, my left subtree is completed. Once the left subtree is completed, I'll have to apply the same formula again, which is left root right. So therefore, I'll visit node 1, which is the root node, and finally visit root 3, which is the right node. So I hope you guys are clear with this. Okay, so now moving on towards the next traversal, which is the pre-order traversal. In a pre-order traversal, the root node is visited first, followed by the left subtree and then the right subtree. So in this tree example over here, I'm going to visit the root node first, which is 1, then come towards the left subtree, following which I'll move towards the right subtree. Therefore, the order will be 1, 2, 4, 5, and 3. Now let's get back to our Jupyter notebook and implement this. So I'm going to define a function, that is a pre-order function, and I'll pass root as a parameter. So if root is present, I'll have to first print the value of the root node. So root.node data. And then I'll have to do the pre-order for the left child first. So root.leftChild, and then pre-order for the right child. So once this is done, I'll just have to call the pre-order function. So as you can see over here, the first node to be visited is the root node 1, followed by the left subchild 2, and then the left subchild of 2, which is 4. And then I'm going to visit root 5, which is the right subchild of 2. And finally, when the root and the left subtree is done, I move on towards the right subtree, which contains 3. Okay, so I hope you guys are clear with this. Okay, so now let's move on towards the next topic, which is the post-order traversal. The post-order traversal begins from left, then to the right, and finally the root. So in this example over here, what I'm going to do is start from 4, move on towards 5, 2, 1, and 3. Now this is because 4 is the leftmost child, and at this stage I apply the left-right root formula. So my program is going to check if I have a right node. Towards the right of 4 is 5. I traverse 5 or I visit 5, and then when I've completed 4 and 5, I go to the root node, which is 2. Once the left subtree is completed, I have to move towards the right subtree and then traverse it. In my right subtree, I just have one node, which is 3. And after I complete the left subtree and the right subtree, I apply the left-right root logic again, and then I visit the root, which is 1. Okay, so I hope you guys are clear with that. So I'll get back to my Jupyter notebook in order to implement this. So what I'm going to do is just define a function that is post-order, and I'll pass root as the parameter. The first thing that I'll have to do is visit the leftmost child. So for that, I'll just do a post-order for the left child. So root.leftChild, and then post-order of the right child. Finally, I'll have to print the value of the root node. Once this is done, I'll call the post-order function, and I'll pass root as its parameter. Seems like I've made a mistake. Sorry guys, I just missed the if statement to check if root is present or not. If the value for root is present, only then I'm going to do this. So let me just type in a tab for all this, and then I'll execute it. So here it is. My left subtree is visited first, then followed by the right subtree, and then 1, which is the root node. So I hope you guys have understood all of these 3 traversals. So now moving on towards the next algorithm, that is the sorting algorithms. Sorting algorithms are used to sort data in some given order. Sorting algorithms can be classified as merge sort, bubble sort, insertion sort, selection sort, or shell sort. Please make a note, guys, that in this session, I'll be sorting everything in the ascending order. So the first algorithm I'll be discussing in this session is the merge sort algorithm. The merge sort algorithm follows the divide and conquer rule. Here, a given list of items is first divided into smaller lists until it reaches a point where each list consists exactly of one item. By default, a list consisting of one item will be sorted, and the merge sort algorithm then compares adjacent lists and reorders them in the desired sequence. This process is done recursively until it reaches a point where there exists only one sorted list. So I'll just create a heading over here and I'll call it as sorting algorithms, or I'll just say sorting. The first algorithm I'm discussing is merge sort, so I'll just call it as merge sort. I already have the code ready for this. I'll just copy that code and explain this to you all. So as you can see on the screen, the first thing that I've done over here is defined a merge sort function. Now this function will check if the length of the list is greater than 1 or not. And if this is true, it's going to divide the list by 2. Following that, I'm going to sort both the left half and the right half recursively. Finally, I'll create a new list that contains the sorted elements. So over here, I've called an mlist function, but I've not defined it. The next thing I've done over here is defined an mlist function. The first thing that I've done over here is defined what is the left list and what is the right list. Left list contains all the elements from the left to the middle, and the right list contains all the elements from middle to right. Following that, I've taken 3 variables k, I, and j, where k is the temporary variable that I'm using to fill on my final list. I and j over here help me to iterate over the left list and the right list. So while my left list and my right list contain elements, that is when they're not empty, what I'm going to do is, if the value of the item present in the left list is less than or equal to the value of element that is in the right list, I'll place the element present in the left list into my sorted list. Else, I'll place the item present in the right list in my sorted list. So if the value of left list of I is less than the value of right list of j, I'll place the value of left list of I into k. Else, I'll place the value of right list of j into my list of k. If I place the value of left list of I into my list of k, I'll have to increment the value of I, or else if I place the value of right list of j into my list of k, I'll have to increment the value of j. Finally, when I've placed some value for k, I'll have to increment the value of k as well. So once I have all sorted elements, what I have to do is start merging my list. The final part of my program will help me to merge the sorted sublists. So if there's any element present in the left list and it is less than the right list, what I'm going to do is place that element into my new list. Then I'll increment the value of I and I'll increment the value of k. When the left lists are completed, I'll have to place the values present in the right list into k. Once all the elements of right are placed into k, my list is completed. So in the final part of this program, all I'm doing is assigning some value to my list. Here in this program, I've made use of the input function. Now this function will allow the user to specify some list. Since the user will provide a sequence of elements, I'll have to split them, and for that I've made use of the split function. And for all the elements present in my list, I've converted them to the integer. Finally, I call the merge sort function, to which I pass my list as a parameter, and the value of left is 0, which is the first index value, and the value of right is the length of my list. Finally, I'm just printing the sorted list. Finally, I'll have to enter the list of values, so I'll just pass in some random values. So as you can see over here, my sequence is first split, and then it's converted to integers, and then finally, by calling the merge sort function, I have created a list of sorted elements. So now moving on towards the next sorting algorithm, which is the bubble sort algorithm. The bubble sort algorithm is a comparison algorithm that first compares and then sorts adjacent elements, and if they are not in order, it swaps them. This process is repeated n-1 number of times, where n is the length of the list. So I already have a program for this. I'll just copy it. So the first thing that I've done over here is defined a bubble sort function. So like I've already told you all, for every list, I will have n-1 iterations where n is the length of the list. In this program, I've named my list as A, and the number of iterations will be length of A minus 1. And the value of that is stored into variable B. So for every element that comes in the range of B, I need to take that element and check if that element is greater than the element that is present towards the right of it. In case that is true, all I have to do is swap the elements. So a of y will become a of y plus 1 and a of y plus 1 will become a of y. So as you can see, I've given some random list over here. In this case, the length of this list is 4. Therefore, the value of b will be 3. So for every element present in the range of 3, I'm going to take that element and check if that element is greater than the element that is present towards the right of it. So first, I'll take 3 and check if it is greater than 6. Since 3 is less than 6, I'm not going to swap these values. Next, I'm going to check if 6 is greater than 1 or not. So as we all know 6 is greater than 1, I'm going to place the value of 1 in place of 6 and I'll place 6 in place of 1. Therefore, 6 and 1 will be swapped and my list will contain 3, 1, 6 and then 8. For the next iteration, I'll check if 6 is greater than 8. So as we all know, 6 is less than 8, therefore they will not be swapped. So for the second iteration, my list is going to look like 3, 1, 6 and 8. Next, I'll have to perform bubble sort on this list again. So what my algorithm will do is check if 3 is greater than 1 or not. Since 3 is greater than 1, the position of 1 and 3 will be swapped. And my list is going to look like 1, 3, 6 and 8. In the next iteration, my program will check if 3 is greater than 6 or not. As we all know that these are already sorted, they will not be swapped. This process is repeated until the complete list is sorted. So I hope you guys have understood the bubble sort program. Okay, so now moving on towards the next, that is the insertion sort. Insertion sort picks up one element of a given list at a time and places it at the exact place where it's supposed to be. Since I already have a program for this, I'll just copy it over here and explain it to you guys. So what I'm doing over here is, first, I'm going to place my pointer at the second element. So whatever input list I have, I'm going to place the pointer at the value that's present at index number 1. Now to do that, I've made use of this for loop. So for x in the range of 1, the length of a, which is the element present at 2, and throughout the length of a, I'm going to set the element present at a of x as the key, and then I'll store the value of j as x minus 1. So in the first case, k will be 56. So 56 is going to be k. And j will be 1 minus 1, so that is 0. So in the first case, k is 56 and j is 24. The next thing what I'm going to do is check if j is greater than or equal to 0. Here in the first case, j is equal to 0. So therefore, the first half of the while loop is true. The next thing to be checked if k is less than a of j. So if the value present at k, which is 56, is less than the value present at a of j, which is 24, I'll have to swap these elements. Now since these elements are already sorted, I'm not going to do that. Now once that is done, I have to decrement the value of j. Now this step is done because I'll have to check the value of the key with all the elements that are present in the left sublist. In the first case, I just have one element present towards the left side. But for the second iteration, I'll have two elements present. So therefore, if I do not decrement the value of j, I'll not be able to check this value with all the values that are present towards the left of it. So finally, I'll place the value of a of j plus 1 into k, and then I'll move on towards the next value of x, which will be index number 2. So I'll just erase this. After the first iteration of my program, the list is not going to change since the value of 56 is greater than that of 24. For the next iteration, I'm going to make 1 as the key element since it's present at index number 2. So 1 will become the key, and the value of j will be 56 and 24. Now this is because 56 is present at a of 1 and 24 is present at a of 0. And for all the values that are greater than or equal to 0, I'll have to check if the value of the key is less than that or not. So I know that 1 is less than 56 and 24. So what I'm going to do is just remove 1 from here. Repeat. And then I'll place 56 in place of 1. I'll place 24 in place of 56. And finally, I'll place 1 in place of 24. So for this iteration, I'll have 1 followed by 24 and then 56, which is my sorted list. And for the unsorted list, I have 50 and 17. So once this is done, what I'm going to do is take the next element as the key, which is 50. When 50 becomes the key, I'll have to check this key with all the values that are present in the left side. So I know that 50 is less than 56 but greater than 24. So therefore, I'm going to shift 56 to the place of 50 and I'll place 50 in place of 56. After this, I'll have a list looking like 1 followed by 24, then 50 and 56. And in my unsorted list, I'll have just one element, which is 17. Finally, I'll take 17 as the key and then I'll check this key value with all the elements present towards the left of it. Since I know that 17 is less than 56, it's less than 50 and less than 24, what I'm going to do is place 56 in place of 17. 50 will come to the position of 56. 24 will come to the place of 50. And finally, 17 will be placed in the place of 24. So I hope you guys are clear with this. Even though there's a lot of mess on the screen, I hope you guys have understood this. Okay, so let me just erase that for now and execute this problem. So as you can see on the screen, I've sorted my list in the ascending order. So now moving on towards the next, which is the selection sort algorithm. The selection sort algorithm divides a given list into two halves, where the first half will be sorted list and the second half will be an unsorted list. At first, the sorted list is empty and all the elements are present in the unsorted list. The selection sort algorithm will look at all the elements present in the unsorted list, pick up the element that is supposed to come first, and then it places it in the sorted list. The step is then repeated by searching the least element present in the unsorted list and it places it next to the first element of the sorted list. So in my examples, since I'm arranging all the elements in the ascending order, if I have a list of numbers, I'm going to select the smallest element and then place it as the first element of the sorted list. Then I start to search for the next smallest element and place it towards the right of my first element. So I'll get back to my Jupyter notebook in order to implement this. I have the code for this already, so I'll just copy it. So initially what we have to do is assume that the first element is the minimum element. Then what I'm going to do is check if the first element is less than any element present towards the right of it. So in my list, I'm going to first assign 34 as the minimum value. So what I'm going to do next is, I'm going to check if the value of this minimum is less than any value that is present towards the right. So for every element that is present towards the right of minimum, that is x, if that value is less than the minimum value, I'm going to place the value present at my array of y as the minimum value. So for the first iteration, I'm going to check if 23 is less than 34 or not. Since 23 is less than 34, 23 becomes minimum. So after the first iteration, 23 becomes the minimum value. Next, I'm going to check if 1 is less than 23. Since 1 is less than 23, 1 becomes the minimum value. So after the third iteration, I'll have 1 as the minimum value. Finally, I'm going to check if 1 is smaller than 67 or not. Since 1 is smaller than 67, the minimum value will remain 1. Finally, I'll check if 1 is smaller than 4 or not. Since 1 is still smaller than 4, the minimum value is 1. So the first element to be placed in the sorted list will be 1. My sorted list will have 1 and unsorted list will have all the elements, which is 34, 23, 67 and 4. So this is my sorted list. And this is my unsorted list. So once this is done, I'm going to repeat the same thing for the unsorted list again. At this time, 34 will be minimum, and after the first iteration, 23 will become minimum, and for the third iteration, 23 is going to remain the minimum, following which I'm going to check if 4 is less than 23 or not. Since 4 is less than 23, 4 is going to be removed from the unsorted list and it will be placed towards the right of 1, which will become the second element present in the sorted list. So I hope you guys are clear with this. I'll just erase all these drawings and I'll run my code. So as you can see over here, I have a sorted ascending order list. Now moving on towards the next algorithm, which is the shell sort algorithm. The shell sort algorithm allows you to sort elements that are apart from each other. The original sequence of the sort elements follows the n by 2, n by 4 sequence, where n is the number of elements present in the unsorted list. For example, if you have a list of 8 elements, the length of that list will be divided by 2 for the first iteration. As we all know, 8 divided by 2 is 4. Now, the first element will be compared to the element that is present at index number 4. And then, the gap will be produced by dividing 8 by 4. This time, the gap will be 2, and the elements present at these intervals will be compared. Finally, I divide 8 by 8, which gives me the gap as 1. So when I have the gap as 1, I compare adjacent elements, and the final list will be sorted. So what I'm going to do over here is just copy a code that I already have written. So my program over here will first divide the length of my array by 2. Then, if the value of gap is greater than 0, for every element that comes in the range of gap, if the elements present after the gap elements are greater than y, we'll have to follow the insertion sort algorithm and swap the elements. Finally, the gap is divided by 2 again. Since in my case n is 7, which is my list contains 7 elements, I'm going to divide 7 by 2 to find the gap. So 7 by 2, which is equal to g, or the gap, will be nothing but 3. Now I'm taking 3 because it's the whole part of 3.5. So the gap over here will be 3. So what I'm going to do is first take this element 23 and then I'm going to check with the element that is present at index number 3. So at index number 3 is 17. Since 17 is less than 23, these values will be swapped. So after the first iteration, 17 will be at the first place. Okay, let me just clear these drawings and then write down the final list. And then after the first iteration, I'll have 17 followed by 12, 1, 23, which was swapped with 17, 45, 2, and 13. So for the next iteration, I'm going to check 23 with 13. Now this is because I'll have to check after the gap of 3. So since 13 is less than 23, I'm going to swap these elements. So after that, I'm going to have 13 in place of 23, and 23 will be placed at last in place of 13. So once this is done, I'm going to divide the gap by 2 again. So my gap in this case was 3. So therefore, if I divide this by 2, I'll get the gap to be 1.5, wherein I'm going to take the whole number, which is 1. So gap in this case will become 1. So next up, I'm going to check all the elements that are present at gap of 1 and then replace them. I'm going to repeat this until my list is sorted. So let me just clear all these drawings and I'll execute this problem. So as you can see, I have all the elements sorted in the ascending order. So that was all about the sorting algorithms. Now moving on towards the searching algorithms. Searching algorithms are used to search for or fetch some elements present in some given data set. There are many types of search algorithms such as linear search, binary search, exponential search, interpolation search, etc. In this session, I'm going to be discussing about the linear search and the binary search problems. The linear search algorithm is used to successively search for a given element by comparing it with each element of the given array. It is one of the simplest searching algorithms, but very important to understand other searching algorithms. So what I'm going to do over here is get back to my Jupyter notebook. And over here, let's just create a heading again. I'll call this as searching algorithms. The first one over here is linear search. And I'll just paste the code that I have for it. So the first thing that I've done over here is created a function that is going to accept the iterables, the length of the list, and the key element. So if any element present in the list matches the key element, I'll have to return that element. In case the element is not found, I'll just have to return -1. So for every element present in the range of 0, n, that is starting from the 0th index number, and for all the elements present in the list, I'm going to check if any element present in my list is equal to the key or not. In case the element is present, I will return X, else I'll return -1. Okay, the key that I've supplied over here is 16, and my array over here contains some random numbers. Next thing that I've done over here is assign the value of n as the length of my array. Following that, I've taken another variable named match, to which I'm going to assign the value of the linear search function. If the value of match is equal to -1, then key is not present in my array. Else, the key is present at so and so index. So let me just erase these drawings and I'll execute this problem. So as you can see over here, my key is 16, which is not present in my array. In case I change the value of this to 12, and then I run this program, you see that the key is present in the given list at index number 0. So I hope you guys have understood this. So now moving on towards the next algorithm, which is the binary search algorithm. Binary search is used to search for some given element in a sorted array by making use of the decrease and conquer algorithm. Here, the key is looked for by first comparing it with the middle element and then dividing the array into half. The left half is searched if the element to be searched is smaller than the middle element and vice versa. The appropriate subarrays are again divided into half and the process is repeated again. Say for example, if you have a sorted list of 7 elements, the key will be compared with an element that is present at the middle or the element present at 7 by 2, which is 3.5. So in this case, the middle element will be assigned as the element present at index number 3. So in case the key element is smaller than that of the element present at index number 3, I'm going to check the left sublist. If the value of key is greater than that of the value present at index number 3, I'm going to search in the right sublist. So I already have a program for this. I'll just copy paste it. So in my program, I've created a function called as the binary search function, to which I'm supplying the list as well as the key element. Left variable is going to point at the first element which is present at index number 0, and the right element is going to be length of my list -1, which is the last element present in my list. Then I've taken a variable to which I've assigned a Boolean value as false. Initially, the value of this is going to be false. So until my list is not empty, I'm going to divide my list by 2. So if the value of the middle element is going to be equal to the key, I'll change the value of match from false to true. Else, if the key value is less than that of the value present at the middle, I'm going to make the value of r as middle -1, which means I'm going to search only towards the left list. And if the value of key is greater than that of middle, I'm going to change the value of left as middle +1, which means I'm going to check only towards the right of the middle element. Finally, I'll return the value of the matched variable. So in this problem, I've taken 2 examples. In the first case, I've taken an element that is present in my list, and the second, I've taken an element that is not present in my list. Okay, so as you can see over here, for the first case, I have true, and for the second case, I have false. Okay, so I hope you guys have understood this. So now moving on towards something that all of you need to know, which is object-oriented programming in Python. Object-oriented programming is a way of computer programming that makes use of the idea of objects to represent data and methods. It is also an approach used for creating neat and reusable code instead of a redundant one. Here, the program is divided into self-contained objects or several mini-programs. Every individual object represents a different part of the application having its own logic and data to communicate within themselves. So what exactly is the difference between object-oriented programming and procedural-oriented programming? Object-oriented programming has a bottom-up approach, whereas procedural-oriented programming has a top-down approach. In OOPS, the program is divided into objects, whereas in procedural programming, program is divided into functions. OOPS makes use of access modifiers such as public, private, protected, whereas procedural programming does not have any access modifiers. OOPS languages are much more secured compared to those which are procedural languages. The objects created in an object-oriented programming language can move freely within the member functions. Whereas in procedural programming language, data can move freely from function to another function. Object-oriented programming supports inheritance, whereas procedural-oriented programming does not support inheritance. So now moving on towards classes, objects, and the pillar of OOPS in detail. So first, let us discuss about objects. An object is a real-world entity such as a pen, book, person, animal, etc. Objects have states and behaviors. In Python, everything such as variables, functions, etc. are considered to be an object. A class, on the other hand, is a collection of objects, or you can say that it is a blueprint of objects defining the common attributes and behaviors. Now the question arises, how do you do that? Well, the class logically groups the data in such a way that the code reusability becomes easy. So for example, consider an office-going employee as a class and all the attributes related to it like employee name, employee age, salary, ID as the objects in Python. So all the details of the employees will be placed in the class employee. This way, you'll not have to write the code repeatedly for all the employees. Instead, a single class will be enough to determine all the details of each employee. So now I'll just jump onto my Jupyter notebook and show you guys how to write down a class in Python. So I'll just create a heading. So here I'm going to write down the syntax for a class. The first thing that I'll have to specify is the class keyword, followed by the name of the class. Like I've already told you all in the naming conventions, class names begin with a capital letter followed by small letters. So in case the name of my class is my class, my is going to be with capital M followed by a small y and cap C followed by small LASS. So this is my class name. Within this class, I can have n number of statements. So I'll just say statement 1 to statement n. So this is basically the syntax of a class. So now talking about methods. Methods are nothing but functions that describe the attributes and behaviors of an object. Now, let us take an example to demonstrate a class, an object, and a method. Please make a note over here, guys, that it's mandatory for Python class functions to have a self parameter, unlike other languages in Java. Self is nothing but a reference to the current instance of the class, and it is used to access the class variables. So I'll just create a class over here. I'll say class, new class. And within this, I'll define a function, and I'll call it as new function. So like I've already told you all, the first parameter to this by default should be the self parameter. So when this function is invoked, I just want to return hello world. Now once this is done, I'll come out of my class and I'll create an object of my class. So I'll just say object is equal to class. So this is how you create an object in Python. You just have to give a name to your object and then make use of the class name. Sorry, the name of my class is new class, not just class. Next, I'm going to make use of this object of new class to call the new function. So I'll just say print obj.new function. So as you can see over here, with the help of this object I just created, I've called the function which is present in my new class, and therefore it has returned hello world. Similarly, you can have multiple objects and functions in a single class. So now let's take another example in which I'm going to have more than one functions and objects. I'll just copy this. I'll paste it over here and I'll take another function named my function. I'll specify the self parameter as usual. And for this function, I'll just have one return statement that says welcome to Edureka. So now I have two functions and one object. I'll create another object. I'll say object2. And this is a new class object. And through this object, I'll call my function. So as you can see over here, I have two functions, two objects, and with the help of both these objects, I'm calling both the functions present in new class. Therefore, I have an output saying hello world and welcome to Edureka. So now let us take a more complex example of this. What I'm going to do is create a class named calculating. Here, I'm going to find the sum, difference, product, and quotient for different values using more than one object. So I'll just say class, calculating. And within this, I'll define a function, say add. The first parameter should be the self parameter, followed by the variables, that is A and B. Now this function is going to return the sum of A and B. So I'll say return A plus B. Okay, so I'll create a similar subtract function. I'll just copy this, and in place of add, I'll write subtract. And in place of A plus B, I'll say A minus B. Now let's create a function to find the product. So add will become product. And from plus, I'll change it to star. Finally, a function to find the quotient. So this one, add will change to divide. And it'll be A divided by B. So now I'm done with this. I'll create an object called as O1. And this will be an object for the calculating class. Now using this object, I'm going to find the result of each of these. So I'll just say print O1.add, and I'll specify some random parameters, say 4, 5. I'll copy this, paste it here, paste it here, paste it here, and I'll change the names of these functions accordingly. So subtract, product, and divide. Let me change the values as well. I'll just say 12, 5, product of 32 and 55, and divide 44 by 5 or 15. So I have one object that is calling all the functions that are present in the calculating class. In case I want to create another object, I can do it in a similar manner. So what I'm going to do is just copy this. I'll paste it over here, and I'll change the name of this object from O1 to O2. Wherever I have O1 in this, I'm going to change it to O2. So I have 2 objects and 4 methods. Now when I execute this, seems like I've made some error. I've made a mistake in the spelling over here. It's not CLA, it's CAL. So as you can see over here, I've got the output. In case I want to differentiate between the results of both these objects, I'll just write down a print statement over here, and I'll just print a dashed line. So as you can see, the first half contains the result obtained by object 1, and the second half contains the result obtained by object 2. So I hope you're clear with this. So now moving on towards something very important, which is the init method in Python. The init method is a very important method that is always executed whenever a class is initiated. So whenever you create an object of a class, this method will be invoked. The init method is always used in the real-world applications, unlike the previous examples that we just saw. So now, to show you an example of the init method, I'll get back to my Jupyter notebook. And over here, I'll define a class, and I'll just call it as Python programming. I'll just use a shortcut. So within this, I'm going to call the init function or the init method. The init method has 2 preceding underscores, prefixed and suffixed to it. So I'll just say double underscore, init, double underscore, and the first parameter should be the self parameter. So here, I'm going to pass in 2 other parameters, which is name and the age of Python. Once that is done, I'll just bind the self parameter with the name and the age attribute. I'll just say self.name is name and self.age is age. I'm going to define a new function over here, so I'll just say define new function. And again, I should specify the self parameter. And within this, I'll just have one print statement that is going to print both the name and the age. So I'll just say, hi, my name is Python. So that is self.name, and my age is self.age. Sorry guys, I have to specify a plus sign over here. So once this is done, I'm going to create an object of this class. So I'll just say p1 equals Python programming, and then I'll use this object to call the new function. So p1 dot new function. I'm sorry guys, I forgot to pass the parameters itself, so I'll have to pass the parameters. I'll just say name is Python and age is 31. So as you can see, I have an output saying, hi, my name is Python and my age is 31. So now moving on towards object-oriented programming methodologies. Object-oriented programming methodologies are nothing but the pillars of OOPS, which are inheritance, polymorphism, encapsulation, and abstraction. So now let's move on and discuss each of these in detail. The first thing that I'm going to be discussing over here is inheritance. So what exactly is inheritance? The method of inheriting the properties of a parent class into a child class is known as inheritance. It has a number of benefits such as code reusability, where we do not have to write the same code again and again, and we can just inherit the properties we need in the child class. It also represents a real-world relationship between the parent class and the child class. Inheritance is transitive in nature. If a child class inherits properties from a parent class, then all other subclasses of the child class will also inherit the properties of the parent class. So now let me just show you all an example of this. I'll get back to my Jupyter Notebook. So I'll just take two classes over here. The first will be the parent class and second will be the child class. So I'll just say class, parent, and then I'll define a function and I'll call this function as first. The self parameter as usual should be specified. And within this function, I'll just have one print statement that informs first function. So next, I'm going to declare another class. I'll just call this class as child. And this child is going to be a subclass of the parent class. So to inherit the parent class, I'll have to specify the parent class within the braces. So I'll just type in the name of the parent class. Within this, I'm going to define a function named second and the self parameter to it. Now this function will also have one statement, that is the print statement saying second function. So once this is done, I'll create an object of the child class. I'll just say obj equals child. And then using this object, I'm going to call the first and the second function. So I'll just say obj dot first and obj dot second. So as you can see over here, this object is able to access both the functions, that is first and second. The first function is not present within the child class, but since the child class is inheriting the parent class, this function is visible to the child class and therefore it is able to execute it. So what we are actually doing over here is subclassing the child class. Calling a constructor of the parent class by mentioning the parent class name in the declaration of the child class is known as subclassing. A child class identifies the parent class by subclassing. So now moving on towards types of inheritance. Depending upon the number of child and parent classes involved, there are 4 types of inheritance. The first is single inheritance, second is multiple, third is multi-level, and finally hierarchical. Single inheritance is when a child class inherits only a single parent class. So in the previous example, my child class is inheriting just one parent. This is an example of single inheritance. In case of multiple inheritance, the child class will inherit more than one parent. So what I'm going to do is just copy this. I'll paste it over here. And then I'll just call this as parent 1. I'll declare another class as parent 2. Even if you do not specify these braces, it's going to work properly. Within this, I'll just define a function. I'll call this as third and the self parameter. And then I'll just print multiple inheritance. So here my child class is going to inherit parent 1 as well as parent 2. Then my object is going to invoke both these classes. So as you can see over here, in the first example, I just had one parent as the base class. But in this example, I have 2 parent classes and a single child class. The object of this child class is able to invoke the functions present in both the parent classes. So I hope you've understood this. The next is multi-level inheritance. Multi-level inheritance is when a child becomes a parent class for some other class. I just paste the previous code and over here, I'll create another child class. I'll say class child2 and I'll inherit the child class. I'll define a new function. I'll just call this as function and the self parameter, and I'll print multi-level inheritance. So here, instead of creating an instance of the child class, I'll create an instance of child2. And then I'm going to invoke all the functions using this object. I'll say obj dot function, and I'll run this. So as you can see over here, all the functions are accessed by this object. So now talking about the hierarchical inheritance. Hierarchical inheritance involves multiple inheritance from the same base or parent class. So in this case, I'll have two different child classes that are inherited from the same parent class. So what I'm going to do over here is just paste the code, and then I'll have another child. I'll call this as child2 itself. And this is also going to inherit the parent class. This is the hierarchical inheritance. And then I'll create two objects, that is for the child class and the child2 class. So obj.1 will be an object for the child class 2. Let me just change the name of this function. I'll just copy this, paste it over here, and I'll change the name of the function from second to function. Okay, sorry guys, I just forgot to change the name of the object over here. As you can see over here, both the child classes have executed and returned the result accordingly. Similarly, you can also have hybrid inheritance. Hybrid inheritance involves multiple inheritance taking place in a single program. So just to show you all an example of this, I'll take this code, I'll paste it over here, and I'll create another class. I'll say child4 or I'll say child3. And this is going to inherit the child class as well as the parent class. As you can see over here, I have more than a single type of inheritances. The first type you see is a single inheritance, and now I have multiple inheritance as well. Similarly, you can have any other type of inheritance also. So I'll just define a function, say function2, the self parameter, and then I'll print hybrid. Okay, so now let me create an instance of this class. Just copy this. I'll paste it over here. I'll remove these objects since we've seen their output. So as you can see, I can have multiple inheritance as well. So now talking about the super function. The super function in Python allows you to call a method from the parent class. So to show that to you guys, what I'm going to do is take the original two classes, which was the parent and the child class. I'll just paste it over here. And within this function, I'm going to type in something called as super dot the name of the function that's present in the parent class. So that is first. So now let me create an object of this. I'll just say obj equals child, and I'll execute the function present in the child class. So I'll just say obj dot second. Sorry guys, I just made a mistake. I specified capital S in place of small s. So let me just execute that again. So as you can see over here, in the previous example, I had to explicitly specify my object to call both the functions present in the child class and the parent class. But over here, my object is accessing the function present in the parent class by making use of the super function. So now let's move on towards the next pillar of OOPS, which is polymorphism. Polymorphism defines the ability to take different forms. By making use of polymorphism, you can redefine methods in the child class with the same name as that of the parent class. Polymorphism is taken from the Greek word poly, which means many, and morphism, which means forms. It means that the same function can be used for different types. This makes programming more intuitive and easier. In Python, we have different ways to define polymorphism. A child class inherits all the methods from the parent class. However, in some situations, the method inherited from the parent class doesn't quite fit into the child class. So in such cases, you will have to re-implement the method in the child class. This can be done in many ways, such as using different functions, class methods, or objects to define polymorphism. So to understand this clearly, I'll get back to my Jupyter notebook and show you all an example of this. So I'm going to have different classes which will have functions with the same names. So let me just define a class called as apple, and this class will have a function called type. Within this, I'll just have a print statement that is going to tell me if this is a vegetable or a fruit. So as we all know, apple is a fruit. I'll just type in fruit. And then I'll create another class called as potato. Here, I'll create a function with the same name, but with a different implementation. And instead of fruit, I'm going to type in vegetable. Let me just change the name from type, since type is a very general keyword in Python. So I'll just say type of. So now I'll create two objects. I'll say obj1 and obj2. And by using these objects, I'm going to invoke both these classes. So I'll say obj1.typeof and then obj2.typeof. Now I'll just run this code. So as you can see over here, even though I have two functions with the same name, my objects are able to access the right function and return the output. You can also have polymorphism along with inheritance. Polymorphism, like I've already told y'all, defines method in a child class that have the same names as the method in the parent class. So as discussed in inheritance, the child class inherits the methods from the parent class. Also, it is possible to redefine a method present in the parent class in the child class. This process of re-implementing a method in the child class is called as method overriding. So now let's take an example of that. I'll just define a class called as bird, and within this I'll define a function called as information. Now within this I'll just keep a general print statement, that is to say that birds are very pretty. So now I'll create a subclass of this class. I'll just say class, and I'll specify the bird as parrot. I'll inherit the bird class over here, and I'll define a function, and I will redefine the function information. Here, I'll just print parrots can fly. So now I'll just create an object of the parrot class, and I'll say obj.information. So as you can see over here, when I've called the function information, which is present in both the base class and the inherited class, the function present in the inherited class has been executed. So that means I have redefined or overridden my method that is present in the base class, and that method has been executed. So that was all about polymorphism. Now let's move on towards encapsulation. Encapsulation deals with binding up the data together with the code that is used to work on that data. This not just makes our code clear, but it also helps in preventing data from being modified as well. In OOPS, a classic example of encapsulation is a class. A class encapsulates all the data and the code such as variables, methods, etc. Data that is encapsulated can have three types of access specifiers in OOPS. These access specifiers are protected, private, and public. Members having public access specifiers are visible throughout the code. Protected members are visible just within the class and the subclasses, whereas private members are visible only inside the class in which they are present. Even the inherited classes will not be able to access them. So one thing I want you all to know over here is that Python in real has nothing such as privacy model. It does not have exclusive access to modifiers such as C++, C#, or Java. Therefore, there are no truly private or protected attributes in Python. Now, I'm sure you'd be thinking, then what is the use of preceding single and a double underscore in Python? Members that have names with the preceding double underscore are mangled in order to protect them from clashes with the inherited classes. Subclasses are also allowed to define their own private members, which will not interfere with those of the parent class. This is why they are considered to be private. They are accessible outside the class, but less is the chance of a clash. Mangling in Python is achieved by prefixing any such name with an extra underscore and the class name. This in turn provides an effective namespace. So in case I have a class named parent, so I'll just say hash parent, and if this parent contains a member with a double underscore, so I'll just say underscore double underscore private member. At the compile time, this private identifier is going to convert to underscore parent double underscore private member. So as you can see over here, the name has been mangled. So therefore, in case I try to access this private member anywhere outside the class by just making use of a double underscore followed by the private member name, I'll get an attribute error. Similarly, if I have a child class, I'll just say child. And if this child has a private member, then at compile time, it's going to be something like underscore child, double underscore private member. So I hope you guys are getting this. The names of members preceding with a double underscore are mangled such that you have an underscore followed by the name of the class and then the name of the member that has a double underscore. So what I'm going to do over here is I'll define a class, say A. And within this, I'll call the init method. Through this init method, I'm going to invoke the so-called private method. So therefore, I'll have self dot double underscore hi. The name of my method is hi. I'll declare another method called as hello world. So this method is just going to print hello world. So here I've declared a method named hi, but I've not defined it. So I'll just define double underscore hi, to which I'll specify the self parameter again. And I'll say print welcome to Edureka. Now I'll create an object of this class. And first, by making use of this object, let me try to call the hello world function. So as we all know, this object will be able to access the hello world function. So I'll just execute this. So as you can see over here, I have both the outputs, which is welcome to Edureka and hello world. As you've seen, I've not called this function which contains a double underscore, but I still have the output to it. Now, if you guys are wondering why the output is seen, now this is because I'm calling the double underscore hi method through the init method. As I've already told y'all, the init method is always executed whenever I create an object of this class. So in case I do not write this method, so I'll just delete this from here. And then if I execute this problem, you'll not be able to see the output for the hi function. In case I want to invoke this function, I cannot directly use obj.hi. I'll have to type in obj.underscore a double underscore hi and then execute this. So I hope you guys are clear with this. The name of hi has changed from double underscore hi to underscore a double underscore hi. So what happens when you have a single underscore? Let me take another example to explain this to you all. So I'll just say class base and then I'll define a single underscore class. I'll just say single and I'll just print saying single underscore. Next, I'll define another class called as double underscore or just double. And then I'll print a message saying double underscore. Now I'll create another class, which is the child class of base class. And through this class, I'll try to access both the functions present in the base class. So here I'll just type in self dot the name of this function, which is single. Sorry, I forgot to define a function over here. So I'll just say define function 1 with the self parameter. I'll define another function with the self parameter. And then I'll say self.double. So now let's create an object of the child class. So I'll say obj equals child. And I'll call obj dot function 1 and function 2. So now let's see what happens. So as you can see over here, the function having a single underscore has been inherited and executed by the child function. Whereas the function that contains a double underscore throws an error saying child object has no attribute named underscore child double underscore double. So in case you want to execute this, All you have to do is just type in the name of the base class preceded by an underscore. So I'll say underscore base, and then I'll hit run. So as you can see, now both the functions have been executed using the object of the child class. So I hope you guys are clear with this. Now moving on towards the final topic of this session, which is data abstraction in Python. So abstraction basically means to show the necessary data and hide the implementation details. This not just increases the efficiency of the code, but it also reduces its complexity. For example, consider your washing machines. You know what happens when you press certain buttons such as on, off, save water, set water level, change program, etc. But the actual implementation of these programs is hidden from you. You do not know how it's being turned off or turned on. You do not know how it knows to take less water or more. This is called as data abstraction. Abstraction can be achieved by creating abstract classes. Any class that contains an abstract method is called as an abstract class. So what exactly are abstract methods? Abstract methods are those methods which just have names but do not actually contain any function definition. So that means that you declare an abstract class but you do not define it. These functions are also called as unimplemented methods. Therefore, an abstract method does not have any body. In Python, this can be achieved by making use of the pass keyword. However, an abstract method needs to be redefined in a subclass where it's being used. To achieve abstraction in Python, you can make use of the ABC module, that is the abstract base class module. So to show an example of this, I'll get back to my Jupyter notebook. I'll just type in a heading. So the first thing that I'm going to do is import everything that's present in the ABC module. So I'll say from ABC import star. So this is going to import all the necessary functions that are present in the ABC module. I'll create a class over here called as bank, within which I'll have a function that describes the name of the bank. I'll have another function that is going to find the location of the bank. But this function is going to be abstract, or I'm not going to have any function definition. Next, I'm going to define a child class called as location, through which I'm going to redefine the abstract method. I'll just define a class bank. So the bank class is going to inherit the ABC class. In case you want to know what this ABC class does, I'll just add in a kernel over here and I'll say help on ABC. So as you can see, this is a helper class that provides a standard way to create an ABC using inheritance. So now moving on, I'll define two functions having bank name and the self parameter. I'll just print the name of the bank. I'll say HDFC. And then I'll define another function called as bank location. I'm not going to provide the body of this, so I'll just write pass. Now I'll create a child class. I'll say bank underscore location. This is going to inherit the bank class, and then I'll redefine the bank location function. I'll print the location as Bangalore. Finally, I'm going to create an object of the bank location class. I'll just say obj equals bank location, and I'll call both the functions. So as you can see, both the functions have been executed successfully. So this brings us to the end of this session. I hope you guys have enjoyed and learned something new. In case you have any doubts or queries, please do let me know in the comment section and I will revert to you at the earliest. We'll be back with more and more interesting videos and sessions. Till then, goodbye and take care.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!